Okay, so it's been a couple days since the last stream. In the last stream, we managed to get the real-time counter fully working. It ended up being a I don't know what it was. Well, I know what it was. For some reason, I needed to wait for the high frequency clock to set up before I started the low frequency clock. Otherwise, I got really bad accuracy on my low frequency clock. I read through the errata for the NR52 and the data sheet, and I didn't see anything that said that that was a requirement. So I pinged some people, but I haven't gotten an answer back. But the answer is we now have a real time clock that works. I'm going to move the mic away from my face a little bit because I'm redlining. So I don't know what's up with that, but it works now, which is nice. Since the last stream, I've done a little bit of work. But before I get started on that, let me do my plugs up front. Sometimes I do them at the back, sometimes I do them at the front. But yeah, I work for a company called Ferris Systems. We recently launched a service called Rust Experts, where instead of paying a consultant full time, you can kind of subscribe to a plan where you can have us on call. So really kind of like having a help desk for your Rust projects. We have a lot of really great people that work at Ferris Systems who know a lot of really cool different things about Rust. So if you're a company that works in Rust and you don't need a full-time consultant helping you out, but you like having someone on call who can keep you from getting you and your team stuck, then come check out Rust Experts. That's rust-experts.com. But yeah, if you're interested in that, check it out. But otherwise, thanks for watching the stream. That's all my plugs for today, I promise. So since the last stream, I got the let's see. I got the real-time clock working, and then I ended up refactoring some code out. So all of that code for supporting the real-time clock, I have submitted a PR that has been merged to the upstream NRF52 HAL crate. But because a couple of my dependencies still rely on an older version of the NRF52, I've kind of broken those files out into a crate called NRF52 HAL backports, where I really just have the clocks, the delay, and the real-time counter module that are eventually going to get merged into the NRF52, but they aren't there yet. So they live here for right now, and eventually I'll refactor that out. I used to have a folder called hack, where I was kind of hacking on the RTC. I've moved that into, instead of just deleting that, I've created a folder called POCS, or Proof of Concepts, and I've got my real-time counter proof of concept in here. So in case you are going back and looking for something that, or how I got that working, you can check this out. It will probably live here until, I'll try and keep it going. I'll end up having to refactor it. Once everything gets merged. But if you want to see what I did for those streams, you can check it out here. I've gone ahead and cleaned it up so that it has proper modules and things like that. And I might still work on that one in this, in this branch today. And eventually I'll probably copy this out to be the alarm clock crate. Because I plan to have one crate for each embedded system that I'm building. So as a reminder, I'm building right now an alarm clock for my bed. So the idea is that I have a microcontroller that can keep track of time. Since the last stream, I've also ordered some parts. So I picked up a couple different displays, some buzzers. I have some buttons around here already. So eventually I'll start building a little hardware prototype. But for right now, we're still kind of working on the functionality on the dev board. So that got set up. I've pulled in, there's a crate in Rust called Chrono, which is kind of like a really nice abstraction over time, where it handles time consistently, it handles time zones consistently, it handles, stuff like converting Unix timestamps into a human readable date, even things like serialization and stuff. But unfortunately, that crate's not no standard friendly. I looked at it. There was some talk about making it no standard friendly, but it ended up being a little more work than I wanted. And I also, time is a tricky thing. If you haven't read the blog posts, like falsehoods developers believe about time, getting time right is way less trivial than it sounds at maybe first thought. So I didn't want to write all of that myself because I'll probably do it wrong. So I was looking for a crate, and actually, Simon Sapine from Mozilla he's written an alarm or a wall clock for Rust in embedded. It's actually working on that project was one of the first things that got me into embedded Rust. So this was really cool to see that he had made an actual crate out of the time management. But he's essentially taken a small chunk of the total chrono crate and put it into a crate called Gregor for Gregorian calendar handling in Rust. So it does kind of exactly the minimal subset of things that I wanted from Chrono, and it's a no standard friendly crate. So I'm going to be using that. There's actually a couple more things I want it to do, so I have a pull request open for that. Mostly the ability to compare one time to another, so you can say like this time is earlier or later than that time. So I've opened up a PR for that. So I still have a little bit of special wrapper behavior around that in my crate, and we'll see that in a minute. What else have I done? I went ahead and made for my functionality. So Gregor is a library for handling time, kind of just abstractly handling time. I've gone ahead and there's kind of two functionalities I need for an alarm clock. I need a wall clock, so something that thinks about time the way humans think about time. Like it's a clock that is moving forward and it's, this date, this time, that kind of stuff. So that's the time portion or the wall clock portion of it, but also an alarm clock that says, okay, I also have these times at which an alarm is supposed to go out. So I've gone ahead and all the first clever names that I could think of about clocks and alarms and things like that were taken. So I've switched to German and I've made a crate called Uhr, which is German for clock. And in that I've got two kind of modules. I've got Uhr, which is a clock which thinks about wall clock time, and Winkel, which is the German word for alarm clock, and this is what thinks about alarms. And I'll dig into this code here in a minute, but I've actually gone ahead and I've published this crate, perhaps a little prematurely, but I wanted to make sure that the name is reserved. So I've published this. I've already started making changes, so I need to bump my version string here. But the idea is that I don't think that I'm doing anything particularly special here. So if you are doing something similar in an embedded system and you need a wall clock or a wall clock and an alarm clock, the idea is to put all that functionality in a crate that other people can use. So I'll get into what this crate does, but you might want to check out this if you are building something similar in Rust. Very open to PRs for that. So what is that crate? Let's look at that crate first because we're already here. So I'll switch over to my editor. I can give a quick preview. And note the code that I'm going to go over here doesn't match exactly what's in crates.io right now because I kept making changes after I published it. But I'll publish this one shortly. I just figured I was going to work on it in this stream, so I don't want to push another breaking change and then immediately push another breaking change. So probably after whatever we have in the stream today, will probably get published. Winkel means angle. Isn't alarm clock? I have a native German speaker telling me that I am wrong. So let me make sure. Did I use the wrong Winkel? Winkel means angle. Wecker. Oh, in my very sleep-deprived state, I apparently made it Winkel instead of Wecker. Yeah, oops. You're right. Thanks, Hackmaniac. Haha. So, initial thing is going to be changing this. Wecker. This is what I get. So, usually when I'm working off stream, it's because I'm hacking on code at 2 in the morning, and this is my obvious non-native German speaker being, wrong. So, let's, fix that. So not Winkel. Winkel means angle, or like, I know, yeah. So, Wecker, you're very right. Thank you, native German speakers for correcting me, and I will fix that, and, so this is not gonna build, so, haha, first action of the day is looking silly. Good. So instead of Winkel... Wecker. And let's make sure that still builds. Not found. Of course, because I renamed it. See, I told you there would be breaking changes in this stream. No Winkel and Wecker. Well, that makes sense. I thought I was being clever, but 2 a.m. James is not clever. And it was immediately 3 a.m. because there was a. I'm also glad I'm starting development of my alarm clock the day after the summertime transition in Europe. So last night the clocks jumped forward, which means now I have 6 months to make sure that my time zone transition works correctly. And the answer is probably I'm not going to handle it because I have kind of like I'm going to be building today. I'm going to have like an NTP, wireless mini NTP alike in my system. So the answer is my server is going to worry about that, and it's just going to push time to that. Now the native German speakers in IRC are making fun of me a little bit, but that's okay. Because that is funny. So now I have a working, so let's quickly get add minus I, git commit. Not a native German speaker. Git push origin master. Okay, haha. Here we go. It's like it never happened. Cool. So now we have refresh. Wecker, which is the German word for alarm clock. So now let's go through a review of my code. Okay, so there's like I said, there's a couple things that I use in this crate. I'll start with the TOML. So I use Gregor, which is that time library that allows me to not think about time zones or converting Unix timestamps into wall time. I'm also using the heapless crate because we are going to have alarm clocks. We always kind of want our alarms to be we also want our alarms to be sorted in the order of which one comes next, because that's kind of something that is sortable. And you, as an alarm clock, you really only care what the next one is. You don't really need to look through all of them. So heapless, which is a structure that was developed by Jorge or Japarek, to what the heapless crate is essentially kind of like the Rust standard collections module, but it has versions that work with either static allocations or with stack allocations, which means you typically have a fixed upper size where you say, okay, this is my vector that can only hold 20 items maximum. So it might be dynamically sized, but you have a fixed size maximum, which means you can have it has size. Like, it's not dynamically sized, it's fixed maximum size. So we'll be using the binary heap structure in there, which allows me to kind of have like a priority queue. I can insert things in there, and they're always in a sorted order where I can always get the biggest or the smallest one. Or in time, I have a min binary heap, which means I always get the smallest time, which means the soonest time. And then generic array. So the way that heapless does this dynamic size thing is Rust doesn't have generics over size, so you can't have like an array that's generic over the number of items that are in it. Except for you kind of can. So the language itself doesn't support it, but someone has written a crate called generic array, which lets you use the type system through a little bit of trickery to do this. So my crate allows you to be generic over that, so I'm going to have like 8 alarms maximum. If you wanted to have 1,000 alarms maximum or 2 alarms maximum, you could do that. So the crate is generic over that. And we'll dig into that a little bit. But let's look at to begin with. So really, this is... it's important to pick how you store time, because when you're discussing time, especially time that is not associated with a time zone, you want to make sure that you're always using the same kind of base when you're comparing things. So typically the way most people I know of who work with databases and stuff like that, they pick UTC as the consistent time. So I've got this UR structure that it's very similar to how Chrono stores its time, or even Duration stores its time, where it's got seconds, which is, this pulls from the Unix timestamp from Gregor, which under the hood is a signed 64-bit integer. So it can, as far as humans are concerned, it can store infinity time, because seconds plus the Unix timestamp is based on January 1st, midnight at January 1st, 1970, and 63 bits before that in seconds is infinity before, and 63 bits in front of that is essentially infinity in front of heat death of the universe type stuff. So we're gonna essentially assume it can cover all times. Unix timestamp doesn't by default have fractions of a second, and for our embedded system we're probably going to care about fractions of a second. So similar to how the duration type and things like that, we're just going to use a 32-bit nanos, so nanoseconds portion. So you can decide what your time increment is here. Here with my real-time counter, right now I'm ticking my clock every 125 milliseconds, which means it's going to be something like 125 million nanoseconds. But it doesn't really care. Basically, UR supports down to nanosecond precision, and the nanos is always in the range of 0 to 1 billion nanoseconds, which is 1 second, because if it gets above that, it will tick over into the seconds column. Let's see, and the other thing we have is a time zone offset. So in Gregor and in Chrono, Chrono is really powerful because they have time zone definitions where you can use this as essentially a generic parameter on your type. So concretely, UTC as a time is different than Central European time as a time. They're actually two different types. Here I store a fixed offset from UTC, which is kind of like a generic offset. So right now the Gregor crate, because the author Simon lives in, or Simone lives in France. I'm not sure if he's in Paris, but he's in France. So he's on Central European time. So right now Gregor, because it's limited to what his use case is, supports two time zones, and that is UTC and Central European time. And to make this kind of more portable, instead of making this a generic parameter, I just use the fixed offset from UTC, where you can specify in hours and minutes how far you are from UTC. Yeah. So this allows you to have a time zone offset. Right now, Gregor doesn't support ORD and partial ORD for comparing times, so I can't just derive ORD and partial ORD here, but essentially I've done what the auto derive was, where I compare the seconds. If the seconds are equal, then I look at the nanoseconds. If one of them is smaller or larger, then we just use which one is smaller or larger. That's basically what my PR does to Gregor, is it implements ORD and partial ORD for this. So at that point, once that gets merged, this code goes away and it just becomes a derive ORD and partial ORD, because the way derive works is if all of the members of the structure implement a trait like ORD or partial ORD, then it can automatically do it. And what it does is it just does it in the order of the members in here. Actually, this may still not work because time zone offset's not going to implement ORD. We'll figure it out. Maybe this won't go away, but it'll make some other stuff easier. So this allows me to compare times, where I can say, like, I can compare the current wall clock time to an alarm, which if the alarm is also an OR structure, and I can just compare them, and if one of them is smaller than the other, I know that time has already moved past that, or things like that. And again, the internals of this, of OR, don't know about time zones really. They know what the offset is from UTC, but when it compares, it's only using the timestamps, which is always UTC. So it's just comparing UTC to UTC, which should always work. And again, doesn't take into account some stuff like leap seconds. But again, I'm going to kind of smooth over that by the fact that I'm going to have an NTP-like server. So my server is going to think about that. My embedded system's not going to think about that too much. It's just going to say, oh, if there was a leap second, am I past the time where the alarm was supposed to be, where the alarm might be like 12:53 p.m. on Tuesday, whatever date. Yeah. So it's got a couple methods. So it's got increment. So this is in my real-time counter. Every time my counter ticks, I'm going to be calling increment with a duration, and I'm just using the core duration time. So this is the same duration. It's the core version of duration versus standard, but the standard version is just a re-export of the core one. So it's using the Rust duration type. I'm not using my own duration here. And duration internally is just seconds and nanos. So essentially I add the seconds is there. Right now I have an ugly thing because duration has time as a U64 and my Unix timestamp it has it as an I64. So I cast this. This is bad. I should check that this won't overflow to do. Maybe I'll do that. Maybe I'll do a checked add here. Yeah, I'll come back to it. And then it adds nanos, and if the nanos rolled over, and here we can kind of we don't have to be so strict on this because nanos has a range of 4 billion, and we should never be, basically nanos should never exist as more than 1 billion for 1 billion nanoseconds. It can within a function here, but it shouldn't like exist as that for a long time. So I can be pretty safe that I'm adding nanos, and duration makes that same guarantee. Sub-second nanos should never return a number bigger than a billion, so I'm not going to overflow here, so I can be pretty safe about it. If it does roll over, then I just increment a second and I subtract 1 billion off that number. And because these are 32-bit numbers, this is very quick on my, this is going to take a little bit because it's 64-bit and on my 32-bit system, but not a lot. So increments it in place. Incremented is a method for creating a new time incremented from another given time. So this is useful if you have an alarm clock and you want to increment it some amount of time, like a day, so that it shows up tomorrow. So this creates a new one and increments it and then returns that. I have duration, so try duration since, which means like if you want to figure out this is kind of like how you would use an instant. Again, it's not going to be, it's in wall clock time, so if your time zone changed or something on you, or you went into summertime, this might not be exactly how much time, but it tells you in wall clock time how long it's been since something. So essentially, if the before time is after the current time, then we return an error. Otherwise, it calculates how long it's been since there. It's essentially doing similar math. Duration since, just unchecked basically. And then I have a method that's into local date time, and this is really useful if you want to convert kind of this opaque OR structure into something that you can use. Like, I want to print out what time it is in my local time zone. This date time structure, which comes from the Gregor crate, lets you do that. So you take a timestamp, so you give it the timestamp in seconds and your time zone offset, and it gives you back a date time with a fixed offset from UTC. And I also have a method for kind of as a setter method for changing the time zone. In case if you were going from like what happened last night, you went from Central European time to Central European summertime, you can change that. Yeah. I should probably, as a note, in my alarm clock, I should probably have something like this, which also changes all the alarms. But I'll get back to that. So that's kind of the wall clock time. So again, it's a module for thinking of time in wall clock time like people do. You could use this for saying like, I want to send a packet at this time in the future. It may or may not be a good idea because if, like I said, if things like a leap second happens, things like you switch into summertime, it could cause some problems. Like if your clock rolled back and you were supposed to be sending a message every 5 minutes, and all of a sudden your clock rolled back, so now you're back an hour. Now you won't be sending messages for an hour. Or if you roll your clock forward, you'll send a message again really quick because the time is incremented. So you can do stuff with the wall clock time. It may not be the best idea. We'll see what I end up doing. But yeah, that's the normal disclosure of it's why Rust has an instant type, is because that is monotonic in that it's not affected by leap seconds and things like that. It is only an increment of time, and we may end up making a instant type in this that is just counting the ticks or something like that. We'll see, maybe. For the stuff that I'm doing, it's not safety critical or anything like that. So if my stuff acts weird for like an hour, it's probably fine. But I say that now until I get, until I make a lock for my house and then I've locked myself out because something doesn't work. Oh well. Okay. So my Vecca, which is an alarm clock, it contains a time, so it knows kind of what its base time is, and then it's got these alarms and this kind of where clause around stuff here. This is how the generic array structure does that generic oversize. It looks weird. You don't have to think about it too hard, but essentially I have a clock and then I have a binary heap of alarms, which are represented as UA types, and I do this just so I can compare two of them reasonably. Alarms is my number of alarms, so this is generic over basically how many I can have, and specifically this is a min binary heap, which means the lowest item is first in a queue. So you can think of it as a priority queue with the soonest first order, because alarms, you always want to see which one's soonest. So I have a constructor method, which is from, which you give it a time, basically, and then it creates a new alarm clock with no alarms in it. So this is like from an UA, which is nice, or just like you give it a timestamp and it does that. And then I basically just have one method, which is alarm ready. So right now I don't have like getters and setters for the alarms. They're public, so you can just like vector.alarms.push, and you can push a new alarm time in there. And then the other one is I have alarm ready, which processes all the pending alarms. So essentially I have this kind of while loop that says while my alarms, and I do a peak, which means I don't pop the item off the front because that might take effort. I think it's O log n or n log n. I can't remember. Heapless tells you. But it looks at the front one. If there was something, so if I don't have an empty list of alarms, it checks whether the alarm is less than our current time, which would mean that we've passed the time that the alarm was supposed to go off. And because this is an option, so map means only do this if there's a sum, and then I do unwrap or false, which means if basically I did get something and it's true, so like here I'm going to have an option alarm basically, which is an UA. And then here I'm going to have an option bool. So this map is converting from like one type to another. And then here I'm going to convert it into just a bool, which means like if it was a sum bool, then it returns whatever that bool was. If it is a none, then it returns false, because basically I'm just checking how many alarms are. And I do this in a while loop because theoretically you could have multiple alarms that go off on the same time. Or you could have advanced time a lot and you could have missed a couple of alarms. Like let's say we were powered down and we wake back up and oops, we just passed a bunch of alarms. So this can process all of the open alarms. And in this while loop, so this is just the condition of the while loop. Inside of it, if we get inside of here, we know that there was one that is ready. So we're going to go ahead and pop the first alarm, which is the soonest alarm off the front. And then right now, just as like this is what I was doing while I was hacking it together, if that alarm triggered, then I reschedule that alarm 24 hours from now. So I increment that alarm exactly, 60 seconds, 60 minutes in an hour, 24 hours in a day. I push it forward 24 hours. Eventually, I'll probably want something like scheduling, like this is an alarm that fires on weekdays. This is an alarm that fires on weekends. This is an alarm that fires weekly. Like let's say I get up extra early on Mondays or something like that. I can have an alarm that just does on Mondays, but I'm not there yet. Maybe I'll work on that today. So then I push the alarm back in, and because now the time is incremented, it kind of gets sorted back into the heap where it's supposed to go. And then I mark this flag as true, which means I did process an alarm. And then once I've processed all of the alarms, I return the flag, which is basically, did we trip over any alarms? And if so, return true. So now I'll go back into that RTC POC, and you can see that I'm using that UA library types. And I've added in a resource called alarm clock, which is a vector which has a size of 8. So this is how that generic array stuff works, is there's a constant associated with that. And yeah, heapless const. So this is all in here, where you use a type parameter. So instead of just being able to use a number, because you have to use like a struct that represents the type or the size, until Rust implements numeric generics, which is coming, but it's not ready yet. So this says I support up to 8 alarms. So right now I just picked an arbitrary Unix timestamp. So for my testing, I just picked an arbitrary Unix timestamp. This is like 3 a.m. last night when I was working on this. Someone can do the conversion into Unix time. So I created a new alarm clock with the time. So like the time that the alarm is actually counting, starting here. To do is basically implement my RTC or my NTP server so that this is correct. So like some fancier real-time clock external hardwares will have a battery backup where they keep counting. This is just using the real-time counter of this. Eventually I'll be able to go to low power mode, and my real-time counter will keep counting even when I'm in low power mode, but that will require my device to have a battery on it, and right now my device has no battery on it. It only is plugged into USB. So whenever I unplug USB, my counter stops counting, and I don't even store this to flash, so it forgets. So right now I kind of am just hard coding that. I also set my local time zone to this is Central European summertime. So right now I kind of hard code that to Central European summertime. Eventually I might want to, I don't know, I'll do something. And just for testing, I pushed in alarms where I take my base time. I have 2 alarms that happen to be exactly the same time, 10 seconds after the device starts. I have an alarm that's 20 seconds after it starts and 25 seconds after it starts. So you can see I push these all in. I could even like shuffle these a little bit so that you can see that, you know, the alarms get put in the right order. And then, you know, I create my alarm clock. My idle loop is basically doing nothing. It's calling Cortex-M ASM wait for interrupt. So this is really like idle. Every time that you're sitting in the idle loop, it's basically just saying wait for an interrupt to happen. And right now the only interrupt I have is my real-time counter 0. In my real-time counter 0, because I know that this is firing every 8, or it's firing 8 times a second, because that's what I configured it to do. My tick time is duration from millis 125. So this is basically my interrupt handler for the real-time counter. I clear the interrupt. Right now I toggle the LED. I increment my clock time by my tick time, so it's always going to be 125 milliseconds. And then I process my alarms. If I had an alarm, then I will write, then an alarm happened, and right now I just write that out to a log. And right now I just am step downing my steps, and I'm just printing out the time to show that I can display this. And this is that date time structure. So I call my resources alarm clock time into local date time. And this gives me a structure where I can just get the hour, minute, and second from that. And then I write that out as a log. And I just keep incrementing my steps, and I toggle an LED. So let's look at what that looks like. What are you doing? J-Link. So I'm connected to my device, and let's do a cd pox RTC poc cargo run. And I also over here need screen, and you know what? Actually, let's not use screen. let's use timestamp so that we get some timestamps on this. And let's run you. So you can see it's 3:51 a.m. and we know that 10 seconds after it goes off, it's going to fire off an alarm. So at 44, it should fire off an alarm. Ha! Okay, cool. So it crashed. Why'd you crash? It's actually not in... Where are you? Push unchecked. Is it not pushing my alarms up? What a funny demo. I bet it's probably because I changed... Okay, well, you know what we can do to debug this, because I've implemented debug on this. Let's, instead of just logging my... Over here is what I'm looking for. Let's... Right before we alarm, because I have a feeling that's where it's, well, let's do it here. Let's look at what our data structure looks like to figure out what I have done wrong. One of my running jokes is that doing demos, hardware demos are like a nightmare because you never know what the hardware is going to do, and then wireless hardware demos are an even bigger nightmare. But you know, this is why I'm streaming. Not everything goes perfect. So I'm gonna get a lot of output now, but that's okay. Oh, right, and it's gonna do it every... Well, that's okay, I'll just wait for it to crash. Okay, so let's take a look at what it's trying to do. Okay, so this is... Let's separate these. Seconds, nanos. Probably should do this for the last one, not the first one. Let's, you know what, let's try and... No, this actually probably isn't what I wanted to do. Okay, let's actually... Let's do that. That's probably about what I wanted. Ooh, I wonder if... I wonder, because this is less than or equal to self.time. I wonder if it's getting in here because the alarm is equal to time exactly. And then this is doing... This isn't incrementing it, so it's just going over and over. I wonder if... Let's see. Let's just actually, before I... Wonder if it's just getting caught like that. Yeah, I think that's what it was. Oops. Yeah, it was the fact that I had two different conditionals there. So it was basically a great off by one error where it was saying that the alarm was ready because we were at exactly the alarm time. But then because the alarm wasn't greater than the current time, because it was exactly equal to the current time, it wasn't bumping it. So it was just stuck in this endless while loop, which is why in embedded for safety critical stuff, you should never have unbounded while loops like that. So oops. Normally you have like a, you know, you should have a counter or something that says like, if you're going more than 8, you're doing something wrong. Okay, so this is now working. Okay, cool. So now let me give you an actual demo of what's going on. And let's remove that extra debugging. You're what? You're the whole alarm clock, so get rid of you. Okay, so we've got, you can see the time, now my time just isn't incrementing. Awesome, did I remove something? Burp, burp. Oh, yep, it helps if you don't get rid of the time increment. Okay, so now my time is ticking again. So again, at 44, we're supposed to hit an alarm. Look, we had an alarm. And then I think the next one's at 20, so it would be at 54. And then 59, we should have one. Yep. And then you can't see it, but I have verified it, that it does shove those back into the back. And you notice that it didn't go off 4 times. It went off 3 times because 2 of the alarms were there. And so it processed all the alarms there. So this is kind of our proof that the clock works and my time is wrong. But, you know, what are you going to do? Let's see. So let me give myself a to-do list. To-do list. Let's see, I have a notes repo, don't I? I have a notes folder. So let's make our notes in here. Okay, so to-do list for myself. What do I need to do? I'm not going to sort this. I need to implement some kind of alarm schedule for stuff like weekly, weekday, and weekend, because I know I'm going to have different alarms for different days. Although I've read you're supposed to wake up at the same time every day, but you know, I like sleeping in on the weekend. I need my NTP light, which actually might be more work than I initially thought, because for that I need something to receive the new time. So this is in my actual alarm clock. And I need something to send the new time. And what I'm actually probably going to end up having is, I'd like to have, like, if this is my network of IoT devices, I'd like to have a single server which has a like a pass-through modem. So essentially, like, I have my embedded system, but my embedded system doesn't do any thinking. It just receives commands to send packets. And then some kind of server-side client. So I'll have my, like, Internet of Streams server. And then I have all my nodes. And then for all my nodes... yeah, and then like both of these need some kind of protocol. And yeah, we've done a really simple serialization and deserialization. The problem is, for the pass-through modem, I need a protocol over UART for TX and RX. So basically, like, the modem, all it's doing is just queuing up outgoing packets and incoming packets and sends them at certain times, and then notifies the server. And I'm gonna need that framing stuff. I'm gonna need that COBS framing from there, because we just have that stream, like with the radio packets, we have packets, really. But over the UART that's gonna be talking from my computer to the modem, I just have like a UART stream that's going to go on there. So I'm gonna need some stuff there. And I'm gonna probably need a server-side client. What I'm probably gonna end up having is like a Rust application that runs on Linux that has like one thread or one process, essentially, that's sending data to the modem, or like queuing up packets to be sent and received from the modem. I'm probably gonna have something like a web server that allows me to go in and, for stuff like my alarm clock, like through a web interface, I can set my alarm clock and stuff like that. Or at least like a REST server that I could use to build an app or something, a desktop client or a command line client that lets me interact with that. So I'm gonna have something like modem comms thread. I'm gonna have something like a web server UI or REST to interact with network. All my nodes are gonna have to like process messages, so I'm gonna need some kind of structure that just handles dispatch of messages, and for each device says like, I am processing this message or I am not processing this message. Because, for example, I'm probably gonna have one unified protocol for all of my embedded systems. And for example, my alarm clock's not going to care about, I don't know, I'm thinking about making a collar for my dog so that it can have like LED lights on his collar for nighttime. So the alarm clock's not going to care about dog collar commands, and the dog collar is not going to care about alarm clock commands. And ideally, I'd like that not to be compiled in, how to process those messages, but we'll find out. Or we'll find out how good the linker is at stripping that out, and if not, I might come up with another scheme for that, because I really don't want, like, if I have 100 messages for 20 different devices, I don't want all 20 different devices to have the decoding and encoding code for all 100 messages. I only want them to have it for the 2, 3, 4 messages that they need to know how to process. So yeah, my NTP Lite's going to have a bunch of stuff. It's going to need like all this stuff eventually. Yeah. Let's see. Maybe I'll work on the scheduling stuff. Because I think I could do that pretty reasonably, and I can simulate that. Okay, I'm gonna take a quick break, real quick, and then I'm gonna come back, and I think I'm gonna work on that scheduling thing where I kind of work in, instead of just having the alarm clock keep track of like the next time. Um, each alarm is gonna also have its like reschedulable thing in there, and I think that's gonna be interesting because I'm gonna be building. I need to look at stuff like days of the week and things like that. So I'm gonna take a quick like 5-10 minute break, and I will be back. So yeah, see you soon. Yeah, if you have any questions, make sure you ask them in IRC, and be back in a minute. Okay, so I'm back. Let me. Okay, so I have. Oh. Okay, so during the break, I looked at Twitter and I had someone recommend something to me that I had seen before, but I want to bring it up and plug it because it's a really cool project. So Texitois, I don't know if I'm pronouncing that correctly, but Guillaume, um, has built probably a much better version of what I'm going to build, in a much classier housing too. So I'm planning on building something sort of like this, but with wireless connectivity, and maybe not with a sensor. Or so they have built a rusty clock using one of these really cool WaveShare e-paper displays with a speaker and some really classy looking arcade buttons on top. So definitely check out this project if alarm clocks are your kind of thing. But I realized, so I had seen this mentioned a couple times and it didn't come to mind, but I realized that Rusty Clock had actually solved some of these problems like date times and alarms and stuff like this. So now I wonder, I am reinventing the wheel. So that's unfortunate. So, um, hmm. So I wanted to actually try not looking at this because this is something that works and is really good, and I don't. Oh, it's too good. So I'm probably gonna end up making a not quite as good version of this. I may end up using an e-paper display in mine as well. I picked up a couple e-paper displays, but I'm gonna want a backlit display. So either something like an HD 44 780, like the kind of like, you know 2 by 16 or 4 by 20 kind of displays that you see on a bunch of stuff, or maybe even just a basic 7 segment display, like the classic alarm clock kind of display. I also had some people suggest VFD displays, which are those cool kind of glowing blue VCR style displays. Yeah, I know. RealProf is bothering me now because this is right now we're collecting projects in the showcase, and now I'm not gonna suggest my project into the showcase as the first thing because then it'll be another alarm clock and people will think that the only thing you can do with Rust is build alarm clocks. But the thing I needed most in my house was an alarm clock, and this is a project that I've been meaning to work on for like 6 years. Like I bought parts like 6 years ago to do basically this, where the whole gist was to have an alarm clock where the off button's in another room. So I'm gonna keep working, and my alarm clock is going to be fancy because the off button is going to be in another room, and it's not going to be as nice as Guillaume's alarm clock. So you should go, if you want to look at a classy project, you should go look at Rusty Clock, because it is a very well put together project. So I would recommend checking it out, and I'm going to do all of the terrible things of duplicating code functionality, and maybe I'll suggest some PRs or something to their project, or we can collaborate on something. I may end up using also a WaveShare e-paper display, like for kind of this more detailed like time and date stuff. I might use this. I bought a bunch of e-paper displays, but I might use it for some other stuff. Like one of the other projects I may end up doing is making kind of like a message board in my house so that my wife and I can send like reminder messages to each other. And when I say reminder messages, she can send me reminder messages because I have a terrible garbage memory and she has a wonderful memory. So she can send me reminder messages. Right now we use post-it notes on the door because that's the only thing that I can reasonably remember. But I may have a really simple like 7 segment clock that's readable at night, and then also have like upcoming alarms and date and weather and things like that, kind of like Guillaume has here, as an e-paper display. We'll see. I'm sorry that I'm duplicating functionality. So you probably won't see this project in the Rust showcase first, but oops. Okay. Well, and yeah, I may not use a 3D printed case. I bought these. I'm going off camera. I bought these interesting wood boxes. They're not quite project boxes. I think they're supposed to be like bathroom soap boxes or like toiletry boxes or something like that. I got 2 different sizes. Kind of like a classy looking wood box made out of bamboo. Can't really see it. It's an IKEA box, but it's hollow on the inside. So the plan is to kind of like drill through and make a panel here and put a hole in the back, because also I don't have skills at CAD, so I could probably figure out 3D printing or pay someone to do the 3D printing for me, but what I'll probably end up doing is just using this box and buying a Dremel and cutting a hole out of it and put it next to my bed or something like that. I don't know. We'll see. But yeah, I'm literally the worst. Now I'm stacking boxes. Oh no. So sorry for the horrible clunking wooden noises, but I bought those parts like years ago, and you know, as projects go, until you have inspiration, they never happen. But let me go duplicate some more. They even have a nice speaker. I'm just gonna have a tiny little simple piezo buzzer, so mine will be an objectively worse version of this. So definitely look here for inspiration, not to me. My only selling feature will be it will be connected to the internet, which means I can make it worse and it will still work in the very spirit of Internet of Things. Okay, so let me do my alarm schedule thing. That'll make me feel better about that. Okay, so yeah, let's go into this library. Oops, I should mute my. Let me just close WhatsApp so it's not making dinging noises, because I don't want to hit mute and accidentally mute everything. Okay, cool. So what do we need to do? We need to have some kind of way of storing when these alarms are going to go off. I guess the two ways that I could do this is I could either just have an enum that's like weekdays, weekends, weekly. The other option would be to have a Boolean field that says like, is it gonna go on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday? I think I'm gonna do the simpler one, which is just the enum for right now, because I know that's also gonna store. Like, I probably should just use a bit field. Should probably go look at the bit flags crate, because there's a flag for doing. Well, let's go. You know what? Let's go look at the bit flags crate. So, unlike C, Rust does not have a built-in bit flags structure, but there is a handy crate for this, which I believe is no standard. I'm almost certain is no standard. Actually, I'm gonna be really upset if it isn't no standard. Let's go look at the cargo toml and see if they have a standard feature. They don't, but in source lib, is this no standard? No standard, cool. Is no standard compatible? Yeah, this is probably what I'm gonna do. I'm probably gonna use and I should only need this for figuring out when the next schedule is. Let's see. Yeah, I could do this. And 0 flags. Okay, well, let's use this. Let's see how this goes. So I'm going to use bit flags equals 1.0. They're on 1.04. That's fine. So we're going to use bit flags, and then I don't need this in the clock. I only need this in the alarm. So let's use bit flags. Bit flags, because this is a macro. Bit flags. Pub. Struct. Day flags. This is going to be a U8 because we only have 7 days in the week. So const. Do I need to make pub const? I guess probably. I guess probably not. Const. Do I start on Monday or Sunday? Let's start with Monday. One, two, three, four. 1, 2, 3, 4. Const Tuesday. Will be 1, 2, 3, 4. 1, 2, 3, 4. Let's align these because that makes this easier. Const Wednesday equals OB 0024 0100. I'll do the alignment at the end. Const Thursday equals OB const Friday. I can remember what days of the week are. Const Saturday equals OB 0010. Const Sunday equals OB 01000000. Okay, and that makes sense. And then let's align these for beauty. Okay, so I have this, and then they had a thing for making collection-y things. Okay. Const weekends equals self. Saturday self. Sunday const weekdays weekends, weekdays. Do you still build? Yes, you still build. Okay. So the other thing we're going to need to look at is, so this really I think only matters on the rescheduling. Because the alarms are stored as UTC time. So probably the way I'm going to specify this is you need to tell me the first time that it happens, and then you need to tell me what day flags is in there. And it should probably do some kind of error checking where if you schedule something on a Wednesday and it's for the weekends, that won't be allowed. So let's, I should probably hide that alarms module, but I'm gonna, well, let's move. Okay, so I probably need a new, so new has no alarms, pub fun, insert alarm, and it's gonna take a time. Does it want to take a Unix timestamp? Probably should take a Unix timestamp because that's consistent. And it's gonna take repeat. Should I make this an option? Because I know that there's, they mentioned some stuff with empty. I guess the default value is 0, so 0 is just empty, so if the repeat is none, then you would give it none. Okay. Okay. So I was basically wondering whether I should make this an option or not, and the answer is it doesn't need to be an option because there's already an empty flag on there. So repeat is going to be a day flags, and this is going to return a result. And I don't have an error type yet, so we're just gonna use the beautiful. Again, I'm sure there's a name for this, just the astounded eyes result. So we should probably is this going to get into weird behavior where if you set an alarm at 12:01 Berlin time and you want it to repeat. This is the problem between UTC time and local time, because if you set the time as, like, let's say I set an alarm, I want an alarm to go off at 11:01 p.m. in my local time zone, and that's on a different day in GMT. And if it doesn't match, is that a bad thing? It's probably a bad thing. But the alternative is I need to, I guess I'm already taking an UA, which has date time associated with it. So I probably actually shouldn't, let's call this first time, and it's gonna actually take an UA that has time zone information associated with it. Then we get into the question is if like the time zone changes, do you want it to still be the same time? For example, if my alarm goes off at 7 a.m., I want it to still go off at 7 a.m. So yeah, I really do want the time zone information associated with it because the UTC time is going to change, but not the wall time. Okay, well, let's keep going with this. I'm sure I will come up with some like unit test failure cases, and this will just prompt me to write some unit tests to make sure that it handles the cases that I want to test, and I can show you how to write a unit test for a no standard crate, which should be nice. Let's see. So I want to insert an alarm. So probably first I need to, if repeats, verify that first instance is on a repeat day. And then really probably just then just insert. I can't think of any insert if there is space. I guess it being full would also be a reason to throw an error. So I probably need a type here that is an alarm. Now I'm mixing languages, which is wonderful. That is going to be the next time is going to be an and the repeat is going to be a day flags. So I probably need to derive debug or partial ord, and it's probably gonna eq partial eq. And I probably should just be doing this all on the time because the repeat is only kind of used. This is gonna not be happy. Oh, well, maybe. Unimplemented. It does work. Huh. That's actually worrying. I wonder how ordinality is handled for this. Automatically derive for the structure the derivative attribute additional traits. You know, I should just implement this manually because I know what I want it to be. So I'm gonna nab. Nope, that sure isn't what I want. Because I really only want it to measure the time of the next alarm in terms of ordinality. Alarm, and I really am just gonna dot next time comp other next time. That's really all there is. And don't auto derive because I derive it. I don't derive it, I implement it. Ordering. Do not use core atomic ordering. Okay. That's good. So now it's only going to think about that. Because we really only need the ordinality for putting it into our binary heap. And we only need to put it in our binary heap sorted by when the next one's going to happen. So we're going to need to turn this into a date time. So let's go look at our main RS because I do that there. Into local date time. This is the actual method that I want. So let first time date time equals first time dot into local date time. And well, okay, let's say if not repeat dot is empty. So we only do this if it repeats it all. Yeah. So we look at the date. Let's validate that. So I'm going to also look at Gregor's documentation because I get a date time out of that. And I need the day of the week. There's probably like internally these are probably actually totally consistent, and it's using, well, no, it's probably using numbers and not bit flags. But do I just want, no, because it could repeat on multiple days. Can I get an iterator over? No, because I just need to check the first one is there. So I don't know. Let good equals match first time date time dot, what was the method? Day of week. Day of the week. And I should use Gregor day of the week. Monday. You know what? And then how do you, in bit flags, how do you check if I need to use, okay, that's fine. Day of the week. Okay, you know what? I'm just gonna have, let's just have a let's just have a impl from day of the week for day flags, function from, let's just save ourselves from day of the week and return a day flags. Let's just match DAO. Use create day of the week star. Let's see. Monday. Can I just get a selection? Edit, convert case. Okay, cool. So let's save ourselves some typing. Edit, convert case to title case. What? Monday. Yeah, I know. So this is gonna map to day flags. So that should be that. So now I should just be able to check, instead of having a match, I should have a day flags from ftdt dot day of the week and repeat. Set complement. Let's see. There's probably a more clever way to do it, but does not equal 0. Because basically what I'm doing is I'm anding this together, which means if any of them overlap, then we're good. Yeah. So if we're good, if not good. Return error. Let's make an error type. Struct error. No, enum error. Enum error. Alarm repeat. Alarm. What should I call this? What do I call when the alarm not on repeat? The specified alarm does not occur on its specified repeat date. Cool. That's a fairly return error, and turn this into error. Expect day of week flags. Oh, is there like an empty set? Is empty. There's probably like, let me go look at the example generated. There's probably flags. Okay, it's just not equal day flags empty. Is there like an is empty? Oh, cool. There is. Dot is empty. Oh, there's just an intersects method. Cool. Cool. Day flags from dot intersects repeat. Extern create day of the week. I can never remember how the whole enum. Okay, whatever. I guess it's not crate. Whatever. I can never, like, you used to be able to do the wildcard matchy things. I can't remember how you do that now. It's the 2018 edition. It changed good things, but sometimes I forget things. Vector error declared as private. Yep, cool. Where's my enum error? Pub enum error. Cool. Someone on IRC is asking which one STM32 RS. It's just one of the ones from STMF44. I'm helping someone on IRC. Please hold. Thank you, stream. Gotta help people on IRC. Okay, cool. So I have a thing. I also noticed that my battery is going down. So apparently my 45-watt power supply is not enough to power my laptop while I'm streaming and compiling code. It is very slowly going down, but it is going down. But that's okay. We're just gonna get this implemented, and that's gonna be it for today. And I might do some more stuff off stream. It's kind of nice to be able to just talk about stuff that works. It feels like I don't end up staring at an empty screen, but I like a mix. If you have strong feelings, send me a message, leave a comment, something like that. So if it repeats, verify the first instance is on a repeat day. Cool. does that. Insert if there is space. So now we should just do self dot, right, but I need to actually change the type. So that was, clock should not be, alarm should not be an anymore. They should be an alarm. And now it will no longer compile. Alarm, alarm, alarm. So all the places where this is an array length now it needs to be an array length alarm. Yep. Let's see. 131. Alarm dot next time. While 139 dot next time dot next time restricted or okay. Okay, so this is very wrong now. Doo-doo. Very wrong. Let's see, I probably need something like days until, because I need, like, if I have a Tuesday or if I have a Friday and I know that my next time this runs is on a Monday, I should probably figure out how many days until, which means I should probably go look before I get all excited and build stuff on my own. Let's go look and see if there's any, like, is there like an add to ISO number, clone, ecop, no. Blanket implementations, not there. I need, I'm sure there's some absurd bitwise math that I could do here to find, like, the segment of zeros between the current one and the next one with wraparound. Let's not. What is the fastest way to do this? I probably need a method that's like find I can think of some not efficient iterator ways to do this, but okay, so the problem that I have is I want to, like, given a start date, I need to find out how many days is it until the next one. Okay, so actually let's start cleaning this up. Let's see. Let's make function fung days until next. That takes a current, which is going to be a day of the week, and a repeat, which is a day flags. I should probably make these references, but references to U8s don't make sense. So, and this returns a U8. And this is going to be an unimplemented because we're just going to pretend that I've done this already. So if we know there's an alarm ready, let's move this up because if not alarm dot repeat, so repeat or repeats, I should probably be consistent about this. Repeat is the parameter, repeat is that. Okay. If not dot is empty, so if there is no repeating going on, you know what, let's not write drift. If empty, continue, because we are done here. This is actually, this honestly might not be the most unreasonable. Okay, I'm gonna do this. This is awful, but you know, let's see. We need to do two things, because if we really miss, like if the alarm was like a year ago, we need to bring it to current, and then yeah, we need to bring it to current, because if it's before now, we need to bring it up to at least the current time, and then we need to pick the next time that it will happen based on its repeat. So this probably needs to be use leading zeros. The real prof use leading zeros could work. The problem is I also need to handle the wraparound case, because like as I've defined stuff here, like if we're on Friday and I need leading zeros -1, and then I need to handle the wraparound until Monday, or let's say I repeat it only on Thursdays and Fridays, I need to like rotate and shift yeah, actually that might work. I could probably put the current date there, and then I could probably put a shift of essentially, like I could put the repeat flag in front. Oh, yeah, you're right. Okay, let's get fancy. Okay, so okay, what is the bit flags for like get the underlying type? Because there should be like the just can I get you as a okay, bits. This is a U32, but it's gonna give me a U8. So let cur equals, okay, this is gonna get tricky. Day flags from cur. And let me let U8 equals cur dot bits. Does this compile? Okay, I need an unimplemented. I think you are right, real prof. I think I'm going to use some fancy bit math here. So what do I need? There's leading zeros and trailing zeros, and I need the zeros between. Let's go look at the. Okay. Let's go look at this, because there's going to be Rust leading zeros. Yeah, leading zeros. There's going to be a bunch of fancy primitive types. Is there like a count zeros? There's no like Okay, and also the problem is that there's only 7 bits of 8 used. Okay, let's go come up with a test case here. Okay, let's say I'm going to copy this. I'm doing ridiculous optimization stuff now that I shouldn't be doing, but it's fun and you know, it's a weekend. So I guess the original idea would be if we repeated repeats on Friday, on Thursday and Friday, just fired on Friday. So I've got Friday, and I've got Thursday. So let's say this is my current date and this is my repeat. So really what I want, because I know that repeats is non-zero, because otherwise we wouldn't be here. I should probably assert that it's not there. So what I really need to do is I need to take the OR of, let's get rid of these. I need to do that. So shift it over by 7. And then I need to shift over until 1. So is there a way to reverse? So I need trailing bits. Trailing zeros. Okay. So this is going to be let field equals it's going to be current day, because it's a current day, so there's only going to be 1 bit set. Dot bits ord as U16, ord with repeat dot bits as U16, shifted 7, not 8. So OR that together. And then I need to field dot, or I need to left shift it, field dot trailing zeros plus 1, because I want to get rid of the 1. And then so what I've done here in this is the initial step, so it's basically this. Then I've basically taken it, so this is 000 1 001 0000. So I've masked into that. So let's copy and paste this. Let's put this and then, yeah, okay, never mind, that was good there. So I've shifted this over 7 and ORed it together. And now this should really be something like that. Where did I get that extra one from? Oh, it's an extra underscore. Okay, that's fine. So then this step, which it finds the leading zeros, which is 4, plus 1, which means we consume this, which means now we're at that. Which means now I need the, and then it's just the trailing zeros. So it's 1, 2, 3, 4, 5. No, it should be 7. Thursday. Did I do this backwards? Should it be leading zeros and not trailing zeros? Because it should be 6 days. Let me just walk it manually. So Friday, I am on Friday, and I want to get to Thursday. So I actually need to go 1, 2, 3, 4, 5, 6. Okay, so I need to shift it up 1. Okay, so this is wrong. Okay, let's let CB1 equal cur left shift 1. So now we have left justified it there. Actually, this is actually easier. Although we do still need to mask them together. Because the problem is if we have Friday to Saturday, then it's only going to be 1. But the day of the week is going to be Friday. So I need to OR it together. That's what it is. Okay, so first I need to OR it together so that this week is currently represented. Then I need to put Monday in front of it. So then I do my, because I need to count left. So now it's left justified. Okay, so now I have essentially Thursday, Friday. Yeah. I should just be writing tests for this and just, instead of trying to think about this too hard, or I should just, not let the real prof nerd snipe me into making a bitwise math version of this function. But, what are you going to do? Okay, so I have that as bits. And then I think I need to keep walking, because time moves right to left in this. So I need to put another let cur2 u16 equals cur as u16. Let's, you know what, u16 from cur. Elsuizo is saying in defining an iterator. I could use an iterator. That honestly might be faster. Because then I'm just going to have a maximum of, what, 7 iterations? I just don't, I don't know what I'm going to do with the loop, because I need like an iter repeat. I guess I could just have an iterator, but the reason that I originally ignored that is because I have to like skip, like I could have an iterator that just loop forever and then skip to the number of the day, but it feels like it's, I don't know, I'm going down this because I've been nerd sniped now. U16 from cur, okay, or with U16 from repeat dot bits. This is gonna end up being worse than just the iterator thing. Left shift 7. Okay, so now I have my thinger again. One, two, three, 4, 5, 6. I guess it's just gonna be leading zeros plus 1. Okay, let's double check this. I'm gonna write a test for this because this bothers me. Okay, cur left shift or cur3 equals cur2 left shift cur2 dot trailing zeros plus 1 let cur4. Alright, then the answer is just cur3 dot trailing zeros plus 1. This is going to be U32. Assert four equals let cur4 assert cur4 is less than, well, really it should be less than or equal to 7. Because you can't have more than 7 days. Cur4 as U8. This is awful. What is this code? Trailing zeros, is it without an E? Zeros. Okay, let's write a test because this bothers me. So I don't think we can put a test module in there. Let's config adder not test no stood that's not actually how it works, because I'm in a workspace and the workspace doesn't like what I'm doing. Let's manually override cargo test target. Okay, so that works. Let's get a... I can never remember what the syntax for this is. cd temp cargo new lib demo test cat source. Thank you. Okay. Mod tests. Okay. Days until test. Cert eq. Use superstar. Date of the week. Thursday. Day flags. Friday. 1. Nice easy test. Assert. Right, actually call the function. That's not how formatting works. Let me make sure it does fail. Sweet. Okay, and let's get my other one where Friday, day flags Thursday. Let's get my wraparound case, and this should be 6 days until the next one. 1. Haha. Did I save? Yes. How do you get 1? Oh, right, because it has to repeat. Like, repeat has to contain day flags Friday. Okay. Today is Friday. The next one is Thursday. Okay, so I have been the real prof. I will never forgive you. So today is Friday. Friday is 10,000, and then repeat is that with the one before it. Repeat is this is like an interview question. This is like an embedded interview question. I'm not happy about this. I've given myself an embedded interview question. And I'm burning up stream time chasing something ridiculous. But hey, let me know in the comments if this is what you like or what you don't like. Okay, so what have I done? So cur ORs that together. So today is also this. So now today is, or cur1 is this. Oh, you don't want to OR with the bits. I think this is just wrong. I think, or you want it, but you only want the days that have not passed. Okay. Because you have to mask off all of the bits in the front. So this shouldn't be cur2. This should be this is okay. I'm sure leading bits is probably like actually an iterator, or is actually like a loop. So I'm sure this is garbage, but okay. Cur and repeat dot bits. Let And I'm sure once I'm done with all of this, the real prof is going to link me to like a solved version of this. Curb dot trailing zeros plus 1. Okay, cool. And let's add a couple more tests just to make me happy. And I should probably let's throw in a debug assert. Yeah, let's throw it one level up. Debug assert cur dot not repeat dot is empty. Assert cur intersects repeat. I guess that's a superset of that. Haha, caught by my own debug assert. Okay, let's add one more test that is weekdays. Friday should be Saturday, Sunday, Monday, so it should be 3. Cool. And then, you know what, let's throw a weekend in there. Sunday, weekends. So Sunday should be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So it's 6 days. Yeah. Okay. So this works. Thank you, The Real Prof. Actually, I really want to look at the assembly for this, because it's gotta suck. Like, it has to suck. Like, I don't know what the trailing zeros implementation looks like on ARM. I can go look at it. I'm ridiculous. Okay, that's enough of that. It works. It's probably garbage. That's fine. But hey, we got an excuse to write a test. So that's nice. I guess the first test I've written for this project, but you know, hey, what are you gonna do? You know what? I have that. Let's go ahead and add. Let's add this in my Travis YAML. Okay, cargo build all. Cargo test manifest path equals or cargo.toml. So oh. Linux GNU. Hopefully all of our yeah, Suizo, it works. I don't know what the delay is. Usually it's like 45 seconds or a minute, but yes, I have it. It works. There are tests. I'm going to pretend that it's super optimal because it's all bit math, but it's probably not. These probably are like no ops. This is like a match statement. So that's going to be like a for loop. Let's see, we got an or. We got a shift in an or. Trailing zeros, I bet, is just going to be like a jump loop. Like, I guess it's probably going to be about whatever our iterator is, but whatever. Okay. So this still hasn't solved the problem of getting us to when we need it to be. The real prof is saying there is a Cortex M0, there's a CLZ instruction, which I'm guessing stands for count leading zeros. Is there a count trailing zeros? Arm. Arm count trailing zeros. Because if there's a count leading zeros and not, well, what do they call leading? It's leading left to right or right to left. I guess, well, so the real prof specifically, I'm using a Cortex M4F, so I'll have this, but I can understand. Oh, there's an R bit, so there's a reverse bit, I'm guessing, instruction. Most ARM compilers support CLZ as an intrinsic, and you can eliminate the branch using conditional executing. Interesting. Yeah, I may end up wanting to reverse the bit order of this so that I can make it leading zeros, but that's also a hyper optimization. What have I done? Yeah, I'm gonna leave that for now. Real prof, the current one. Do you think I could? Well, you know what, the real prof, I'm gonna snipe you back, and I'll leave this as is. I will accept a PR that if you can show me a Godbolt, like a compiler explorer, that renders to less instructions on the Cortex M4F target, even if you switch all of my, I'm totally happy if you switch all of the order of my bit flags for my days. I don't care. I'm just using them as opaque bit flags. So you can change this, like you can reverse the order if that makes your life easier, or even make them like bump up to the front. Tell you what, you submit a PR. I will commit this after the stream, and if you come up with something in Godbolt that is less instructions, I will publicly thank you on the next stream. As much as I've publicly told you how much I am annoyed, but make sure the test still passed. But yeah, I'll leave this as this is right now. And you know what? I'll clean this up too. U8 from cur4 and oxff. It's not going to like this, is this? Because it's going to be like, you might have overflows. Yeah, whatever. I asserted. You know, let's make that a debug. Assert. Yeah. Okay, what else? Okay, so this still hasn't addressed one of the core problems, which is like, I need to advance to time. So the other thing that I need to do is figure out like how many days you already nerd sniped me. I ordered more e-paper displays and parts for a custom driver. Ooh, did I nerd snipe you? Because I just ordered a bunch of I ordered a bunch like on the wave share. Let me go find EPD wave share. EPD wave share. Kmore. So I don't know which ones you ordered through Real Prof, but I listed the ones that I ordered here. So I ordered these wave share displays. So I got the 4.2 yellow, black, white, the 4-2 black and white, 4-2 red black white, the 7-5 black white, and the 5-8-3 red black white. So I'm going to be working on these ones. So if you want to work together on one of these, my plan is to, there's this EPD Waveshare repo that has some really cool built-in embedded HAL driver support for this, and I plan to work on this. So like I plan to add whatever functionality. They don't support color displays as far as I know, so I'll probably start with the black and white one just because there's already support for it. And I think this is also what Texatoy is using in their Rusty Cluck. But yeah, I wanted to play around with these. I may use these for like a message board type thing. Okay, I'm getting long in the stream. It's already been like 2.5 hours, including breaks and stuff. So let's try and wrap this up. I'm gonna leave. The question is, how do I I should probably increment this like week at a time. Okay, so what's my problem here? My problem here is, let's say our next alarm was supposed to go off on a Tuesday, and we didn't boot up until Wednesday. And so now we need to like, or really Tuesday of last week, and now we need to, yeah, maybe I get rid of that. Because I don't think I actually need to intersect it with repeats, because I just need to know how many days until the next one. So I don't think this is actually necessary. I think it is necessary to OR them because I need to know when the next one is, which means I like in case I have that Thursday Friday rollover. So actually, let's get rid of that debug assert, and let's get rid of these, because this should still actually work. Because that's how many days from now until the next one. So actually, I don't think I need to advance time. I just need to take the current time and add the number of days. So I need to not look at the that's just how many rough days there are. Okay, so this will give me how many days until the next one. But the alarm, see, the alarm, I don't really want a full, it really just needs to be a day. So I need to take just the hour, minute, seconds from the alarm and the time zone, but the time zone I think has to be the same. The time zone does not have to be the same. I really should make the time zone have to be the same. Okay, there's some subtle room for error here. But whatever, I'm gonna just put a big warning flag here. And then I'll write some tests. So let alarm daytime equals alarm local into local daytime. You know what? Whatever. This is an unlikely case. Alarm dot increment days until next. Next time dot. I'm probably getting all worried about optimizing things that I don't need to optimize, and I'm tired of that. Dot increment days until next, where what do I need? I need current day of the week, so I need today's. So I need self dot time dot into local date time dot day of the week. Alarm dot repeat times days. Days is gonna be duration from seconds days until next times 24 hours in a day, 60 minutes in an hour, 60 seconds. And then let's just throw that in there. We're just going to bump this forward a week, because we know when the next one's going to be. We just have to get the week right. While alarm is less than self dot time. Alarm dot increment I just need to bump up the clock. Let's just bump it up 7 days. So just bump it ahead a week until it's ready to go. Yup, sure isn't. Alarm dot increment. Alarm dot next time. Into local date time. Oh, you. U64 from. What an absurd set of code I am building here. Remove these parentheses, sure. While alarm dot next time. Okay. Can you multiply date times? Or durations? Plus duration. I think you can multiply durations. Mul checked mul. Well, we've got checked mul, so it must be a thing. Mul U32. Oh, cool. Okay, so actually I can simplify some of this. Const 1 day equals 24 times 60 times 60. Const 1 week duration equals 1 day times 7. Increment days till equals U32 from increment days till times 1 day. Increment one week. Calls and constants are limited to tuple structs and did you not implement mul as a const fn? It's checked mul. Impl mul U32. Impl mul. Mul is not a const fn. Okay, cool. Then let's just do this the hard way. I should probably add some comments in days until next, but, you know. Let's see. Move the... Render the current day of the week as a bit flag. Obtain U8 versions of our flag structure. Overlay next week with this week. Get rid of days this week that have already passed. How many blank days until the next repeat? Our alarm does not support intervals greater than a week. Yeah, okay, cool. So I think I can actually process all pending alarms, including rescheduling. If one or more alarms are ready, this function returns true. Currently, all alarms are rescheduled for 24 hours. That's not true anymore. Alarm doesn't repeat. All done. How many days? Actually, like this immediately just takes this to a U32. So let's just stop this and get rid of. Well, we should still have that. Cur 4, and instead of U16, let's just use a U32 everywhere, and this is just going to return a U32. Because that way I don't have to cast, because there's really no point in downcasting and then immediately re-upcasting until the next firing interval. Just alarm instance. Okay. Increment the alarm to the next period. And then, just in case we lost a lot of time, bump the week until we are actually in the future from now. Because this is only thinking in days, and this is thinking in time. Next time is less than self.time. Should probably debug assert that it's greater than 0, because we should not. I should add a test here that is what happens if it's Thursday and the next day is Thursday. So that should be 7 days, not 0. Cool. Thank you, unit tests. Tomorrow is, yeah. Okay. Okay, cool. So I have comments on that. Let's go ahead and update the, let's update my example. Let's do a rough high level check that everything still works, because I know this is actually going to fail. I mean, this is going to fail to build because the times are wrong and stuff. Do I have a way of inserting an alarm? Yeah, insert alarm, first time, repeat day flags. Okay, that's cool. So let's go into my main, because this has changed. So I need to go look at this. I need to give it an not an alarm. Okay. Let's just get rid of you for a second, and I could probably make this more convenient. There's probably some convenience methods that I need. Alarms.push should not. Well, one, I probably shouldn't make this alarms public anymore. alarm dot, what is it, push alarm, insert alarm, insert alarm. Okay, let's time. Let's let my next alarm equals this. Next alarm, because I have to set the time zone, which is probably pretty error prone, and I should probably not do that or require that. Insert alarm, next alarm, and when do you repeat? Let's Unix timestamp. Let's look at the Unix timestamp now, because that'll make it easier. Okay, so set the time to now, and I want my next alarm, and I'll also need to pull in, I probably also in the lib for this need to re-export that new type. Need to re-export alarm and day flags. Day flags. Next alarm, and let's see, today is a Sunday, so let's just make it day flags Monday. Oh, it's gonna complain that that doesn't make sense. Cool. Day flags Sunday. I might need to look into that a little bit. This is an associated function, not a method. What? Alarms. New insert alarm. Right. Actually finish your work. Self.alarms. Dot. Push alarm first time. No, alarm is next time, isn't it? Next time and repeat. Next time. Map. And then I've got this alarm. Alarms. Full. No space remains to push alarm. Alarm full dot map error. Monday, right, that's all caps, isn't it? Cool. Cargo run. bug. Okay. Did I remember to increment? Yeah, okay, so it's in 10 seconds. So I really should, let's see, on the alarm, when the alarm goes off. Alarm, let's actually out dot clear. Let's actually print our mut out. Resources dot alarm clock dot unwrap. So we should get our alarm clock with the at 36 alarm. Okay, so when is this? This should be, well, we made this on Mondays and Sundays, right? And where's my init? It's hard to navigate. Init, so it's on Mondays and Sundays. So it should be, today's Sunday, so the next alarm should actually be tomorrow. So the date that it gave me for the next one should be roughly this time on tomorrow. It gave me a date that is today. Wait, is that before processing the alarms? Or did it not really pop that alarm? Is this a different one? Convert. Oh, is that the time? Yeah, that's the time. Sorry, this is the next one. Because the time is this. And then the alarm is this, which is tomorrow at 2:11, which is, I believe, 2:11 p.m. UTC. That's fine. And then should be 36. Yeah. Perfect. Cool. So that actually, you know, when you write tests, things actually work. Okay, so let's do this again with just the repeat on Sunday. So this should now be a week later. Oops. And alarms next is 296. So let's convert. And that's next Sunday. Cool. So now I think we have an alarm clock, and it's probably not the most convenient interface to use, but it does in fact work. So it does require you to have time zones for both your clock and your alarms, but hey, that's probably going to be coming from time zones. But you know what? It's been a long stream, and I will think about how to make these interfaces more convenient later, and no one's no one other than me is using them. So cool. Let's wrap that up with -I update 1 through 6. 4, did I add anything? Let's add our notes. Git commit. Working alarm clock with reschedulable alarms. Push origin master. Cool. Well, that is everything. Well, thank you all for watching today. Yeah, worked on the alarm clock. Probably between now and the next stream, I'm gonna think about and work on that modem thing a little bit. So I expect the next stream to be one of two things: either playing with the new hardware that came in, because it should come in tomorrow on Monday, and getting some displays blinking and piezo buzzers blinking, or buzzing, I should say, or putting some more work into making my modem actually happen. So depending on what I feel like in the next stream, it's probably going to be one of those two things. Probably going to be playing with the hardware because that's more fun. Because then I can make an actual clock even if it doesn't have real time. But yeah, thanks for watching. Feel free to leave a comment if you have any questions, or send me an email. The contact information's all in the repo and things like that. So have an excellent week.